Cool. All right. Um, so, hey there. My name is Justin. I work at a company called Lattice. We are building an on-chain game engine called Mud. The organizers asked me to come talk about autonomous worlds. I'm not gonna do that. Oh, my clicker doesn't work for the dramatic effect. The thing was supposed to be stragged through, but just. Oh wait, there we go. Cool. So I'm not gonna talk about that. I mean, kinda. So AW is kind of like the idealized version of what folks in the little art team I'm on are working towards. But it's not very important to like understand all the philosophical implication of what that is. It's more like a fun way for people to argue with each other about something that is like very far in the future. And it's kind of like you don't have to understand nor believe the concept of nirvana and enlightenment in order to learn meditation. You know, you can just like be like, oh, it's going to be good for my well-being. You don't have to go deep into the Sanskrit teaching. And usually my presentations are like this, and this time, this is a very serious business conference, so this is going to be more like that. It's more put together. So autonomous world is kind of like a concept that emerged from the niche community of on-chain game. The TLDR of an on-chain game is it's a game, a world whose entire state and logic is on the blockchain. So people usually do like the painstaking thing of building an entire game from scratch, and then they move the ownership layer to a blockchain, which like supposedly gives like digital sovereignty rights and all of that. Here, what we're interested in is the idea of like, hey, if you think of blockchain as a new computing platform, not just a fancy way of doing digital ownership, what does it look like to just build games on top of that, right? And as you might imagine, blockchains are said to be slow and expensive and complicated. So like, if you now want to build your entire backend on chain, it's quite a big endeavor. So why should we do this, right? And so the thing you actually do when you build an on-chain game is you can think of your backend as just smart contracts and your front end is whatever. It's not a client technology. It's not about rendering pretty pictures. It's about what is the state of the world and how do people interact with it. So why should we do this, right? And if we look at it from a computing platform perspective, it's a very similar question to like, why should we put games on mobile, right? And so if you try to answer this question, you look at mobile as a computing platform, you look at the affordances and feature of that platform, you look at like what people can do now that they couldn't do before. So with mobile as an example, you can play a game on the toilet. It's a little bit hard with a PC game. You can get like distribution much easily because most people have smartphones. So let's look at the blockchain as a computing platform, right? And one useful tool for that is the idea of a tech tree. So technology is not linear. We're not like progressing and unlocking things in a deterministic order. People go on kind of like explorations and improve specific aspects of a computing platform step by step. So when you think about virtual world, we've done stuff like pushing rendering technology all the way to real-time ray tracing, AI generation, massive cluster networking. So to kind of like double click on this, if you think about networking, what started as single player games evolved into like peer-to-peer session games, and now we have client server architectures. All of these things did not have to happen in this specific order when compared with, let's say, evolutions in visual fidelity. They were just like specific push that were made by people over multiple decades. For visual fidelity, we went from text to moving sprite on the screen to 3D, and now to ray tracing that is asymptotically approaching what nature looks like. From content, we went from literally nothing to dialogues, human-created maps, procedural generation, and now like creating assets end-to-end with AI. And all of these are like little side quests that people made on the tech tree of virtual world. And one important question I think that I've been pondering upon is that are there more branches in the tech tree? You know, like there's often things we've barely scratched the surface of, and then if we were to make a significant effort towards them, we'd be able to discover generally new things that you can now do. So yeah, what are these new branches? And I think one of them comes from this little push that has happened since Satoshi published the Bitcoin white paper, from the perspective of like, hey, let's build computers that are autonomous. And I'm going to expand a little bit on this. Because if you ask, hey, what makes virtual worlds like fair, alive, persistent, independent, mostly for their inhabitants as opposed to for their gods or for whoever is exploiting them, it's a little bit hard to answer that question from a technological perspective. Like, is there some form of like tech that gives you this, right? Is it somewhere on the tech tree? If you think about things like, I mean, you might not know all the stuff in that list, but like SCP, EVE Online, multi-user dungeons, Blazeball, and a bunch of other stuff on the internet that feel very alive and persistent and mostly for their inhabitants. Sorry, my mic is saturating a little bit. Mostly for their inhabitants as opposed to being for whoever is exploiting the theme park. And what I think has been kind of like discovered in this blockchain kind of like endeavor is this idea of ownerless computing. So for the first time, we can build computers that are not owned by anyone, which means we can build programs that are entirely autonomous. You can make a credible commitment to have something keep executing the way it is without any human oversight. And that's kind of interesting. And if we put it there on the tech tree, like what does it look like to keep pushing this and use that as a technology for virtual worlds? So ownerless computing was invented 14 years ago, and it was immediately bundled with capitalism. If you think about it, it's like, oh, we can do this fancy thing, and we're going to make a bank out of it because we don't trust the government. That was kind of like the first feature. And there's a bunch of systems that can kind of like be looked at from the lens of ownerless computing. And generally, people think that, you know, if you take ownerless computing, you slap like a ledger and libertarian value on top of it, you get Bitcoin, and they think that this is the innovation. And I think this stuff is like one of the most epic things that ever happened on the internet. But I actually think that this is kind of like the substrate that will go way beyond like sovereign money. Like the idea that now we can build computers. I mean, they're logical computers created out of networks of computers and incentives that can self-execute is a really powerful idea. We could define it as a distributed logical computer made alive and autonomous by human coordination. You can call it blockchain computing, sovereign computing. I don't think there is like a definition or a name that is sticking yet, but I find it very useful, at least, to think about it from like a platform, like a computing platform perspective. Like, what does the computing platform give you, as opposed to what are kind of like the downstream features you get from that? Instead of thinking of blockchain computing as a way to do digital ownership, it might be more generative to think of it as a new computing platform where one of the features you can build on top of it because of its affordances is digital ownership. We don't say that computers are digital spreadsheets. They're just programmable machines that happen to run Excel if you build it. So ownerless computing doesn't require proof of work, a token, hyper-financialization, speculation, and scams. All of these might be like interesting side effects or historical artifacts, but it's fundamentally a technology that is agnostic to all of this. And I think that bundling ownerless computing with financialization might have been one of the greatest computing tragedy of the 21st century, but it might have had to be done this way. I think that the specific trajectory and path dependency of Bitcoin, Ethereum, and all of that might have been the way to get there. Anyway, cool. So we have ownerless computing. Now what? Why are crazy people trying to build games on top of that computing platform? Similar question, like we have autonomous programs now. Why? What do we do? And I think there are many cool features of this computing platform, but I want to kind of like double click on 3 of them for this presentation. The first one is that they're multiplayer first. The second one is, which is really useful for an investor business conference, is that they give instant financialization. With zero work, you can financialize a world, which is kind of interesting. And the third one is, they bring the cost of making credible commitments almost to zero. So what a credible commitment is when an institution or a person or a machine says X will happen if Y happen. A commitment is said to be credible if like you believe that thing. So as an example, if I go on Discord or on Slack or whatever, and someone texts me saying that they can help me make $50,000 in 2 days of investment, this is not a credible commitment. I probably don't believe them. But if my financial institution or my payment rails tells me that my SWIFT wires are going to be blocked because I have not done my, I don't know, whatever KYC, it's a pretty credible commitment. The reason I pay my taxes is because the government has a credible commitment to fine me if I don't, right? So the thing that is interesting with this computing platform is that now people and machines can make credible commitments almost at zero cost instead of having to build institutions that can enable these credible commitments. And we'll go into this. So anyway, 3 points. First one, multiplayer first. So if you think of blockchain as a computing platform, it enables deep third-party ecosystem at very low cost. The first kind of like reason for that is that anyone can synchronize the state of a blockchain system. So what this would look like is if you guys are developers or if you've talked to developers before, in your game, on your project, you might have like a database, and then you have replicas, you know. What if anyone could sync a replica of your game? That's interesting for many reasons. Now they can project the game in different ways. They can build new clients and all of that. The issue is like, we don't do this because most of the time on our databases, there is private information. We can't let anyone sync a replica. So one interesting first side effect of blockchains is by forcing the ability of anyone to be able to synchronize the state, it has actually pushed the entire field of cryptography forward in order to make it so that we can have private states and privacy on these public systems. So that's like a cool first feature that you get for free. The second one is, which is kind of bonkers, anyone can deploy code in your server. So we've made a bunch of games. The first thing players do is they're going to deploy some code that runs next to our game that executes when some stuff happens. If you try to do this today on a computing platform, let's say you get your AWS account and you like build the game backend, and then your product person tells you, well, we really want our developers or third-party developers to deploy code in our server and execute it when that happens. Your tech lead is going to be like, holy shit, this is going to take us like 1 year. We need to build this like secure computing environment and then charge them for it and blah, 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 blah. So this is another thing you get for free. Everything on these computing platforms is organized as events, and the entire history is observable. So they're history machines, first and foremost, as opposed to being like, hey, you can just see the latest state. One more nerdy details is that these systems all have virtual machines that are made first and foremost for multiplayer programs, as opposed to be for like single-player programs. So another way to look at it is that these systems are multiplayer, but they're built out of necessity. So just like a platform like Roblox can allow developers to come in and build on top of it, they do this out of choice, right? They might do it really well, but it's still done out of choice. The thing that's interesting with blockchains is that there is no sysadmin. There is no god that can come in and clean up the database if something wrong happens. So from like a development perspective, they had to build all of these things out of necessity. And so the same way a theme park can have a governance structure and a mayor if they really want to, they're probably going to spend way less effort on this than, say, New York, which has to build a governance structure out of necessity instead of out of choice. So there's this like interesting tactical thing that is happening here where by defining this platform as a thing that is multiplayer first, all of the tooling around multiplayer computing and letting people deploy code in a server and all of that is really freaking good. Case study of this is Dark Forest. I'm going to accelerate because I feel like, I don't know, how much time do I have? Oh, wow, okay, guys, this is going to be a tough one. Let's go. So Dark Forest is a game I worked on a few years ago. It's a strategy game running on Ethereum where people had to capture planets and all of that. The entire game was running on chain. It was like the first app that was using zero knowledge proof in production, so the universe was secret. Anyway, it was like a very nerdy thing. People loved it. Here's some stats. We had like roughly 10,000 players per round. People built hundreds of extensions. There was like a lot of activity, third-party developer activity. And the thing that's interesting with Dark Forest is what you see is not the world. Like the world is just a set of rules and data. And this thing that's like one of the clients we built is just a specific representation for it. Because at the end of the day, given anyone can copy the state and interact with it, anyone can build a client and kind of like represent this state however they want. The other thing that's interesting is that because it's on chain, it was ownerless, it's always up. Dark Forest is still running today. There's no way for us to actually stop it. It's kind of like this little planet in the solar system that you need specific tools to access, but it's still there. All changes in the game came with a mathematical proof to be able to, we needed that to get secrets on chain anyway. All of that doesn't really matter. The thing that is cool is people were able to create into the world, not around or on top of it, when it comes to like this multiplayer computing aspect. Because what we did as developers is we created rules, not features. I mean, we built some of them because otherwise nobody would play the game. But we mostly define rules. So as an example, this is the broadcast market that was built by a bunch of players. In Dark Forest, there is a rules which is every day you can broadcast the location of a planet to everybody in the game so they can see where that planet is, because by default everything is hidden. So what people did is they were like, well, if there's a specific planet you know of, because we can see all the stats publicly, but you don't know where it is, you can put a bounty for people to broadcast that thing. So they built this, we created a rule. The rule was like, you can broadcast once a day, and then people created a feature, which is, here's a market for broadcasting stuff. This is the night market, which is a way for me and another player to privately exchange the location of a planet trustlessly. We created a rule. planets' location are hidden, people created a feature. Now you can trustlessly, that is, you know for sure it's going to happen, exchange the location of a planet with someone. This enabled deals that were massive in terms of dollar value for people to be able to exchange the location of planets. Of course, there were tons of markets. So what was the rule we had? The rule was, well, there are these things in the game called artifacts. You can send them to other players if you're close enough. That's the only thing we did. It's 5 lines of code. People built the markets and built the features and all of that and integrated them into the game. Because at the end of the day, on these computing platforms, you mostly define what can and cannot be do. You don't define what like the features are inside the world itself. This is my favorite one. So a rule of Ethereum is that machines and humans are treated the same way. They're all addresses. And so what someone made is they built a civilization that plays as a smart contract. So this is the Astral Colossus. It's a machine that is still executing today, that roams the universe, and you can contribute resources to it. And it's kind of like a trustless NPC. This thing is just like, once again, the rule was anything that has an address can play Dark Forest. The feature is like, well, we can build smart contracts that have addresses, so we can have machines that play Dark Forest, that players can read the code of and then trust they will do something specific when you reward them. And to kind of double click on this, there's this idea of like a multiplayer kernel. So traditionally in computing, you have like an instruction set, let's say like x86, RISC, ARM. You might have heard that Apple is moving to ARM. ARM is like an instruction set. And then there's this idea of bare metal, which is like you just write some code that compiles to something that executes in that instruction set. The thing is, most people, what they do is they execute stuff on top of an operating system, something like Linux, Windows, Mac OS. And what an operating system does is it makes it easier for multiple applications to coexist. Because at the end of the day, on a computer, there should just be a single program running, because a program can do everything. And so operating system enabled multiple applications to run on personal computers. That was a huge unlock, pure software. So you can go, but it's still very much like a single person. You could tell me, well, you know, like at my company, we run like Linux servers and multiple people use it. Well, it can be, that's why I would like kind of like go a little bit more precise and say it's for a single party. So a computer right now can be used by a single group of people that kind of like all trust each other or like has some form of like permission system. The thing that's interesting with the chain is that it's a multiplayer virtual machine. So you can have multiple people potentially adversarial with each other coexisting inside the same computer. So same thing, you have bare metal, you could call it bare chain, and you can build on top of it, but a bunch of people, my company, Lattice, Terrence, who's here in the audience, his company, Cartridge, have been building a multiplayer operating system. So if we have a multiplayer VM, now we're building software that allows multiple people to build software together, like a game world, even if they don't necessarily trust each other. So things like Mud, Dojo, etc. are all multiplayer operating system. And so now someone can come in and lay down the core rules, like we did for Dark Forest, but then people can come on top of it from different parties that might not necessarily trust each other or be in the same company or in the same team. They might actually hate each other, like the blue guy and the purple guy hate each other. But they can all build on top of the same state because there's this multiplayer operating system. So that's pretty interesting, right? Because you can do this almost at zero cost. You don't need to build a massive team doing like UGC computing, build a new language and all of that. This comes from day one. Okay, second feature is instant financialization, which opens like interesting new business models. So the Gen 1 kind of like blockchain game is this idea of like, we'll build a game like we've always done on the traditional computer, and then we're gonna move the ownership stuff on like a weird blockchain computer. And then we have to like, I don't know, there's like so many companies that got specialized into, do I have a laser here? Yeah, that they're here. You know, they're like, oh, this interface is painful. Let's get really good at doing that. The idea with an on-chain game and like the Gen 2 crypto games is that you just put the whole thing there in the blockchain computer and you don't really have to care that much about how you're going to financialize it because it comes out of the box, right? So players will be able to trade and generate economic activity if there's any form of ownership that is expressed, however light. Like even if you can steal people's item, they'll be able to like financialize the stuff. You can also make it easier, right? So in one line of code, if you import like ERC20 on Mud or like ERC20 on Dojo, this will make it such that some of your resources will conform to specific interfaces. That makes it easier to build marketplaces. But at the end of the day, there's this fundamental feature, which is that people will be able to, with enough steps, turn things into dollars. It doesn't mean that everything will be like financialized to hell. I mean, at the end of the day, like if I can steal your item, if I come close to you, well, we can financialize it, but the markets are going to be highly inefficient and dangerous, right? So how financialized your application is, at the end of the day, will largely depend on how strong your ownership is. So there are two side effects of it. The first one is like the physics matter. That is, the rules of the game will really matter for this. Here's a Dark Forest war story. So in Dark Forest, there are planets. You know, this is a planet, this is a planet. At the beginning, in the first few rounds, we let people transfer planets from one person to another, regardless of who that was. And then very quickly it got exploited because people could travel faster than light. They would join on one side of the universe and on the other one, give their planet to their other account, and now they were like really far away and they broke the rules of the game. So you have to be careful. If you make things transferable, if you have a notion of ownership, the physics of your game will matter a lot. Another side effect is developers can make money because if developers can build on like your open APIs, you know, deploy on these multiple kernels and all of that, and players have resources that can be turned into dollars after enough steps of transformation, there's a natural payment rail between players and developers to turn things that players already own into payments at floating rates, right? So in one of the games we're building right now, we just launched something on like a test network, and some people are already like building some like match creation tools that players are paying for in like 6 hours, because there's like a really easy like transformation end to end. And the third thing that I'll go over really quickly is this idea of like the credible commitment, which is like now, for very little cost, you know, you don't have to be CCP Games and spend 20 years building EVE Online and not fucking it up for the players to believe that EVE Online is real and will last forever. You can just put it on the blockchain and just write the code that says it's going to last forever. I mean, many caveats. But it's kind of interesting as like, if you think about, you know, a lot of economics is centered around transaction cost, and transaction cost going down means we can do better business. Here we're bringing down the transaction cost of making credible commitments. So if you think about World of Warcraft, right now it runs on C++, but mostly on Blizzard legal operation and cash flow. If you swap this for like distributed networks and consensus, at first the thing will not really change. It will really much look the same. So is it just a server change? Well, if we were to switch, I claim that it's very different from just switching the C++ to Java here, like a different programming language. It's deeper than a server change. Let's illustrate. This is like your run-of-the-mill bank app. That's currently backed by a Swift banking system and a financial institution that protects your deposit. If you swap this from my little brother in my garage that keeps track of all deposit and withdrawal, and there's still the same app, you have a very different relationship with the app, even if it looks the same, because the system is making very different kinds of commitment to your money being available. If you swap this once again with the Bitcoin network that has had 14 years without a hiccup, once again, the relationship you have with this changes dramatically, because the computing platform, I mean, it doesn't have to be a computing platform. The platform itself, my brother is a platform. The platform changes the relationship you have with the system. And so there's like a new relationship that comes from like the autonomy of the system itself. So the cool thing is now we have a possibility, not an obligation, to make a program or virtual world autonomous if it's deployed on a blockchain computing kind of like platform, which is really interesting. And that's kind of what the autonomous world people in this art scene really care about. Is like, how are things going to change if we can change the relationship? So bunch of side effects of this. The first one is you credibly lock APIs, and that's a huge deal. If you can tell developers, hey, you don't have to trust we're not going to change our APIs, we'll literally burn the fact that we can't change our APIs even if we can change our games, that's huge. Like, people now are going to be way less worried of like investing into building on top of your APIs. And that's like a pretty trivial thing to do. The second one is you can provably create neutral systems. So today we have neutral protocol, imagine emails, but we have non-neutral system built on top of it. Email is neutral, but we have like Gmail, Outlook, or whatever. There's no like neutral email client or like email server, because the implementation actually matters because it brings a lot of power. If you compare this to like Ethereum, let's do a case study. There's this thing called wrapped ETH, which is a way to turn ETH into a token. This is the amount of code that wrapped ETH is. It's 81 lines of code. There's $6 billion Ether into this program. And the cool thing is anyone, I mean, you don't need to know how to code to be able to read this program and understand like, nobody can steal my money. Like, there is no one that has like a God access to this that can steal my money. And that makes it such that this little program was able to like kind of like change the world dramatically compared to if we were in the world where like it was different competing people that had to like build the most trustworthy institution to be able to custody these Ethereum. So the ability to make a program autonomous is like quite profound. And we don't really know yet like the extent to which this is going to change like the idea of computing on the internet. So yeah, the cost to credibly commit to the system not changing was $42. This is how much it cost to deploy that code. I checked on the Block Explorer. So with $42, I was able to put, not me, but someone was able to put a code on the internet that has much credibility in some sense, like, or similar credibility to something like the Swift institution that regulates how Swift payments are going around in Europe. And one fun fact, this is the website of Wrapped ETH. At least that's how I found it on the Wayback Machine. It's dead today, it doesn't exist. But this thing is still running. And like this thing is popping. Like people still use this stuff. It's like the base of like a lot of DeFi. But the people that built it are gone. The website is dead, but the program is still running. And that's kind of crazy in some sense. And the third thing is like you enable more serious investments, because if people know that your platform is not going to change, or that they will always be paid 95% of their revenue, or that you will never take more than 30% of fees on the marketplace because there's a provable commitment, a credible commitment to that, you can enable more drastic investment into these platforms, just from the perspective of the third-party developers. So one last thing before I wrap up. There's this game we've been building called Skystrife. We've released kind of like a season 0 launch on like a test network. It literally happened yesterday. And a bunch of fun stuff happened that illustrate really well the concepts I just talked about. So Skystrife is a turn-by-turn strategy game made by us in our in-house game team. It looks like this. It's match-based. 4 players get put into this like really simple pseudo-real-time strategy game. And it was built by game developers. I mean, mostly game developers. They know some blockchain stuff, but they're not the people in our engine team that build the engine. They're mostly game devs. And what they did is as I said, they defined the rules, not the features, with some caveat, because they did build some of them, otherwise people would not play the game. And we got like a bunch of like very light usage. We're talking like 5,000 users on the first day. And here's what happened from the perspective of us creating rules and then them using the rules. So the first rule is that some resources are transferable. People can send it. So in the first hour, people created like over-the-counter deals. This happened in every game where you can transfer items. Has nothing to do with blockchain. But then on the third hour, someone deployed a trustless swap that can allow you to like exchange these like little orb tokens with other people and build liquidity pools. So we never built anything that allowed for this to happen, right? Like this comes as a feature of being on the platform in the first place. And we could imagine in the future that like the resources that there's like sufficient liquidity between the resources and dollars, such that now players can now pay third-party developers at a floating rate very easily, right? The second rule is that MUD, which is the engine Skysurf is built on, exposes hooks, so way to like trigger code on basically everything. And the development team, the team that built Skystrife, made it such that players can set and change these hooks on their own matches, right? So you can choose some code to be executed when a match starts and when a match ends. And on the 6th hour, actually, someone is building a system already that makes it so that you can gate matches with like NFTs. But the point is not the NFTs. It's not stuff you buy or whatever. It's just like he wants to be able to give stuff to his friends such that the matches he creates can only be played by his friends, not the army of bots. And that's kind of interesting because same thing, us enabling people to hook into our system in a way that we know is not going to break our game was super easy. This was like just turning a bunch of flags on, right? And you can imagine that like in a sufficient amount of time, people will be able to build automated league with like MRR being computed for everybody, tournaments, prizes, and buy-in. That's like pretty trivial to do with the platform today. And note that all of these peoples, they don't need to run a backend. They don't need to like put a server up and maintain it and all of that. Their changes, right, like the change they made to the code, they just put it on the blockchain, it lives there, it executes without them, and all of their client changes just neatly integrate into the data flow and the client automatically. So there's this cool thing where someone can come in and with a burst of enthusiasm, build something, give it to the players, and they don't have to maintain it anymore, which is huge. Like if you talk to developers at CCP Games, one of the stories they will tell you about EVE builders, EVE third-party builders, is a lot of them build systems that then players use, but then they don't have the capacity to maintain them forever. And usually a lot of them die. Now that problem largely goes away, again, with caveats. A third rule is that the game data is structured and standard in a way that is introspectable. So everything in the game, you know, like the stats and all of that, is a standard MUD data structure. And what happened with this is, on the first hour, people started building a map even before we released an editor, because they can see what the data structure is, they can introspect it with the MUD tools, and they're already building maps. You know, we do have a map editor, but we've not released it. So we didn't have to program any of these APIs, and we didn't have to think about the code for the third-party dev and the code for the internal team. We don't have like two different split-brain stuff going on where we build for the third-party dev and we also build for the core game. The internal team and the third-party devs are essentially the same from the perspective of the system, just with slightly different permissioning. So it's really powerful. And yeah, that's what I said before. Like, okay, this sentence is kind of insane, actually. Third-party developers can get paid by building custom code running in our server next to game code. That's like a bonker statement. There's like so many crazy things about this. The first is third-party developers. Like this is kind of like the golden thing for like large games today, but this requires usually like a team to think deeply about this. They can get paid, you know? Like we didn't have to build the payment rails and all of that. They can just by the virtue of the computing platform get paid. By building custom code, same thing. Custom code usually requires a team to come in and think about, okay, what programming language we're going to use, how we're going to make sure that the code they execute is safe, doesn't like take away our like server resources and all of that. Running in our server, same thing, that's like usually kind of crazy. How do we make sure they don't escape the control of the VM and blah, blah, blah. So this sentence, like I can make that statement about something like SkyStrive, and from the development team perspective, this required almost zero work, right? So it's pretty incredible from the perspective of like advancing forward the idea of like, hey, the game is not just made by a company, it's made by everybody. Or at least not the core rules, but the features. And so from a computing platform perspective, blockchain is interesting. As a summary, from 3 perspectives, it's multiplayer first, you get instant financialization, and you can make these strange, credible commitments for a very low amount of money. So how do you get involved? Well, I recommend building stuff on top of existing games. You can learn Dojo, or learn Mud. Terence and I are going to talk now about probably these 2 things, so you'll hear more. And I recommend just like playing these on-chain games. And I put play here as a playing these games goes further than using the client. A lot of people that play, they just start like kind of like figuring out, okay, the client is just a view into the system, but playing can go much further than the client itself. And I find that quite interesting. So yeah, go out there, try some stuff. As Alex put it this morning when I said hi, we're in the world of 10,000 daily active users, so most of you should just ignore all that stuff. It's never going to work out. But there's some interesting behaviors going on there. Cool, so that's it from me. Sorry for being so over time. And yeah, I'm going to now talk to my friend Terence. Thank you.